Back to Educator.com, Intermediate C++. Today we're going to look at some real actual code. It needs to be put together and actually run an application. If you've taken the introduction class and you've seen that we've had a little program for making a checkbook account, which we've kind of expanded on a little bit, and we've made it a little more object-oriented, use some of the new features that we should have learned in the intermediate class. So let's take a look at some code here. What we've got here is a MacBook which runs in a Unix-like environment. So these are the files that have been developed so far. The CPP files are C++. The header files, each one has a corresponding header file. So as you can see, we've got the account and date field, exception. So let's take a quick look at the global constants. So we see we've got our include guards there. We have global constants defined. So if the global constants is not defined, then we define them. So we can include the global constants in each C++ file. So even or in each header file for each object. So if an object gets included more than once, or if an object includes another object, these constants will be included and defined exactly once. So we've got a version here set to 0.2. This screen overlaps, but that's okay, or wraps rather. And we have an ini file that we're going to use the same as the previous class, which is probably the worst name in the world that we can use for that, but it's all right. We're not going to worry about that. So next thing I want to take a quick look at. Let's look at the account object. I'm not going to be looking at this in any particular order. I just want to try and cover as much of this as we can in the time constraints. So there's a little quick header block. Now we're including the header file. The CPP for an object needs to include its own header file. As a matter of fact, thinking about it, we should look at the header file first, shouldn't we? All right, so there's our include guards. Now we're using vector, we're using set, we're including string field, number field, integer field, and transaction objects. So here's our definition. We have the account includes here we are. This is our callback function. So when the caller calls our function, we want their function so that we can call them back. So the way this is being used is to make sure that when we make a new account, this account is unique. And so we want the caller to keep track of how many of us there are and what our names are. So if the user puts in one that we've already got, then we will get a function back that says is unique will be false, because that means we've got a duplicate name here, so we can do something about that. So here we have a vector. Now, like I said, if you took the introduction class, you'd notice the transaction was an array, and we had a predefined set of like 5,000. You could have as many as 5,000 transactions. If you had 5,001, you had to send the company money to get an upgrade. Well, here is the upgrade where we're using a vector of transactions. So we can put in as many transactions as will fit into memory. And the other ones, we have an account ID, the file name where we're going to store this account, and then for each account we'll have its name, city, account number, description, transaction count, the next transaction ID. So each transaction gets a unique ID, and we'll increment the next trans ID for that, and the check number. Not every transaction will have a check, because sometimes the transaction's a deposit. Sometimes you just go into the bank and say, I just want to withdraw $100 so I can go down to the casino and lose it, whatever else you're going to do. So you won't have a check number. But when you do have a check number, you want to keep track of it. So we'll keep track of it right here. And each time we use the check number, we'll increment it. And again, the user will be able to override the check number, because sometimes they want to write the same number again, or the number gets too large. They want to start back over at 1001. So the user has complete control over that. But we'll always give them, this is what your next checking number is. It drives accountants crazy when the check numbers aren't in sequence. But we have to allow for the fact that users will drive accountants crazy. So here's our constructor. We have our default constructor. We have our copy constructor, so we can copy an account to another. And here's where we're creating one with a new file name. So we can check, see if this file name unique. If it is, we'll just proceed. If it's not, we'll do something else. Here's where we're constructing it with the is unique function. So we will attempt to create it, and if it's not unique, we will back out of our creation. And here's our destructor and the method startup. So when we make a new account, and if everything's all right, all the rules are satisfied, we'll call startup to start up. And that should be the end. Yeah, and that's the end of this file. So now going back to, let me see if this works. Oh, that works. Good. So here's our copy constructor. So the account ID is set to the account ID. The file name gets a new file name, etc., etc. All that's pretty straightforward. Here is a vector copy where we take our transactions. See, here's our transactions. The empty, the default constructor, we just make an empty transactions. And here we're copying using the assign method to copy the iterators from the begin of the new account transactions to the end. Here we are. So what we're doing is we're taking in this copy that we're doing, we're getting a new account that's being copied to, actually this should have said old account, shouldn't it? Well, I'm not going to change it now. So we're copying from the previous account to a new account, and this is how it's done with the vector. Now this is where we're using a string field if we're having a new file name. This is where we call it. It's not a copy constructor or any other. All we're doing is starting up, and we're getting our callback function and then saving it so that we can use it later. And we don't have anything to destroy, so the destructor is empty. Here's our startup, which just prints out that we're testing. It's because there's a lot more work to be done in this, which is why you're going to have homework assignments.